today's goal of this lecture. Today I will see inner product space just as a review. Actually, inner product space, this topic is very important for higher study. We all of us know in RNCN, inner product X with Y is always denoted as Y transpose X, and this is defined as, this is the standard inner product in Rn, and when Cn, this is Y bar transpose, that means Y star transpose X. This is the standard inner product in Rn, we all of us know. We could define another inner product in Rn also. A different inner product in Rn, if x equal to x1 up to xn and y equal to y1 up to yn, because this is the Rn space, then inner product x with y equal to 2 times x1 y1 plus x2 y2 up to xn yn. This is also inner product in Rn. So another inner product in Rn, inner product x with y equal to C times inner product x with y, where C is positive real number. This is the inner product in Rn. That means this is the standard inner product. Also we could define another inner product in Rn, this type. Also we all of us know inner product x with y is defined as x transpose ay. Here this matrix A is positive definite and symmetric. When A is positive definite and symmetric, then this matrix A is inner product space. I hope my all viewers have understood. Here A is positive definite and symmetric because we all of us know inner product x with y is equal to inner product y with x. Inner product space always be symmetric. That means inner product x with y means x transpose ax, ay, and inner product y with x means y transpose ax. And this is equal to actually x1, x2, here a, b, c, d, and y1, y2 vector. This is equal to y transpose means y1, y2, here the matrix A, B, C, D, and here x1, x2. That imply ax1 plus cx2 bx1 plus dx2 y1, y2 equal to a y1 cy2 by1 dy2 x1, x2. And this is imply Ax1 y1 plus Cx2 y2 plus Bx1 y1 plus Dx2 y2, which is equal to, sorry, here would be y transpose means y1 y2, and here the vector x would be x1 x2, sorry, then this value would be here x1 x2, this value would be a x1 y1 plus Cx2 y2 plus Bx1 y1 plus Dx2 y2. Now cancel this part, then that imply B equal to C. If B equal to C, then inner product x with y is equal to inner product y with x. That means the matrix would be, since B equal to C, the matrix would be A, B, D. And this type of matrix is called as symmetric matrix. So, when inner product is defined as x transpose Ax or x transpose Ay, then always the matrix A would be symmetric. Another condition of inner product, we all of us know inner product x with itself always greater than equal to 0 when x not equal to 0. And inner product x with itself is equal to 0 when x equal to 0. Inner product x with itself means x transpose Ax, which is equal to Ax1 square plus 2Bx1 x2 plus Dx2 square. And if x2 equal to 0 and x1 not equal to 0, that imply Ax1 whole square is strictly greater than 0. And if x1 equal to 0 and x2 not equal to 0, that imply Dx2 whole square greater than 0, that imply obviously D greater than 0. That means x transpose Ax which is equal to A times, since this is equal to Ax1 square plus 2B x1 x2 plus dx2 square, this is equal to A times x1 square plus 2B over A x1 x2 plus d over A x2 square, and this is equal to A times x1 plus b over A x2 whole square plus d over A x2 square minus b square over A square x2 square. That imply A times x1 plus b over A x2 whole square plus x2 whole square over A square times AD minus B square. And notice since x transpose Ax always would be greater than 0, so when x1 equal to minus b over x2, then since x transpose Ax strictly greater than 0, if we take x1 equal to minus b over x2, then this part is equal to 0, then obviously this part would be positive, and this part means AD minus b square, and AD minus b square means since the matrix is A, B, D, actually this is actually determinant of the matrix A, determinant of A. That means always determinant of A is strictly greater than 0. Therefore, I have got A strictly greater than 0, D strictly greater than 0, and their determinant is strictly greater than 0. When A greater than 0, D strictly greater than 0, and determinant of the matrix is strictly greater than 0, we all of us know this is the condition of positive definite. So, when the inner product x with y equal to x transpose ay, then always imply A is symmetric and positive definite. I hope my all viewers have understood this is clearly. Okay? Wait. In matrix, the inner product is defined as, consider this matrix A and this matrix B, then inner product A with B is defined as, in Rn this is defined as such type A12 B12 B12 bar plus A13 B1 A21 B21 bar plus A22 B22 bar, and this is actually nothing but trace of B star A, where M n cross n with complex field, and when real field, then this is actually is equal to trace of B transpose A. Okay? Another matrix inner product is, let VF be an inner product space and beta equal to the basis u1 u2 up to un be the order basis of the V, then A equal to inner product u1 comma u2 inner product u1 comma u2 up to u1 comma un inner product u2 comma u2 u2 comma u1 u2 comma u2 up to u2 comma un. This would be continue, and this is inner product un comma un comma u1 un comma u2 up to un comma un. This is said to be matrix with respect to ordered basis B, and this is called as matrix inner product. As for example, in R2, consider the vector x equal to x1 comma y x2 and consider the vector y equal to y1 comma y2. Then check that inner product x with y equal to x1 comma x1 y1 plus x2 y2. Is this inner product? For this, consider the basis equal to 1 0 0 1. With respect to this basis, the matrix would be inner product u1 u1, inner product u1 u2, inner product u2 u1, and inner product u2 comma u2, and with respect to the basis, the matrix would be 1 0. If we put, consider this is u1 and this is u2, inner product u1 comma u1, this value would be 1, u1 comma u2, inner product u1 comma u2, this value would be 0, inner product u2 comma u1, this value would be 0, and inner product u2 comma u2, this value equal to 1. So notice this is always greater than 0. So that implies, obviously, notice here the determinant is positive 1 and this is also positive, and A and D both positive. So obviously, since all condition is satisfied, so this is be an inner product space. Next, consider another example is in another type. In R2, consider inner product x with y equal to x1 y2 and x2 y1. For this, if you consider standard basis beta equal to 1001, then consider this is u1 and this is u2, then these value would be inner product u1 comma u1, inner product u1 comma u2, inner product u2 comma u1, and this u2 comma u2. So this value is equal to inner product u1 u1, this value would be inner product u1 with u1, this is x1 x2, this is y1 y2. So first u1 comma u2, that means 1 0 with 1 0, and this value would be x1 y2, that means this 0 plus x2 y1, this value also 0, that means this is 0, u1 u2, this value is u1 u2, that means here x1 is 1 and this value is y2 is 1 plus x2 y1, this value is 0, that means this is 1, u2 u1, this value also, when u2 u1 0 1 with 1 0, this value also would be 1, and u2 u2, that means 0 1 with 0 1. So this value equal to x1 y2 0 plus x2 y1, this value equal to also 0. So this value equal to 1, and this is determinant is negative, not positive definitive. So this is not be inner product xy equal to x1 y2 plus x2 y1, this is not be inner product. I hope my all viewers have understood this is clearly. Okay, OL. Next question, on R2 define inner product x1 y1 with x2 y2 equal to x1 x2 minus alpha times x2 y1 plus x1 y2 plus y1 y2. Is it inner product for all alpha belongs to R? Second, if alpha equal to 0. Third, if alpha less than 0, and option 4, if modulus of alpha less than 1. If we consider standard basis E1 and E2, where E1 is 1 0 and E2 is 0 1, then the matrix would be such type, and E1 E2, E1 E1, inner product E1 E1, this value would be 1. So this is 1. Inner product E1, E2, this value is minus alpha. Inner product E2, E1, this value is minus alpha, and E2, E2, this value is 1. So this value is 1 plus minus alpha square. So since this is the inner product, so obviously this value always strictly greater than 0. That imply minus alpha square greater than 1, that imply alpha square strictly less than 1, that imply absolute value of alpha less than 1. So option 4 is the right option. And another easy method, you can construct the matrix such type. Here notice here x1, x2, if you consider y1 or y2, then notice the matrix would be, if you don't consider this method, if you consider only this part, then notice the matrix would be 1, x1, y1, here x1, y1, here this is, and this part is minus alpha, minus alpha. This is the easy method. Here actually the calculation, but if you consider this part, then you can easily find this matrix actually would be this. I will stop here. In my next video, I will discuss some question about non-linear space. Okay? Actually, this topic is very important for higher study. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.